Well, hello again, everyone. Today is day 3. I am going to go over one thing you may have, actually, a couple things you would have read in your reading, and then I'll go over a couple things pertaining to today's reading as well. Give you some more insight into what you will be reading today. But first, I wanted to go over what you have read already. Page 1, 2 of the prologue. I did want to clear up something here, and because something's not quite right here. But in any event, let me just go through this. The most important piece of a typical computer is a CPU. Okay, the CPU is a microprocessor made from a tiny chip of silicon, sometimes as small as half an inch square. Immensely precise manufacturing process etched a huge number of semiconductor devices, called transistors, into the silicon wafer. Each transistor is a microscopic digital switch, and together they control with perfect precision billions of signals. So here's a problem. What are those billions of signals? Little spikes of electricity that arise and disappear every second. Little spikes of electricity that arise and disappear every second. I don't think so. No. How about, guys, let me say this. If little spikes of electricity arose and disappeared every second, a computer would operate slower than a turtle with only 2 legs, okay? It's like little spikes of electricity that arise and disappear every billion times a second. Okay? The size of the spikes, it doesn't matter, only their presence or absence. The transistors in the CPU recognize only 2 states of the signal, 1 or 0, on and off, true or false. Now, something else in the reading here, just to clarify, because well, here we go. Every computer has an internal clock that generates electrical impulses at a fixed frequency. All CPU operations are synchronized with the clock's pulses. The duration of the CPU operations is measured in clock cycles. The CPU speed depends on the frequency of the clock. The Intel 8088 microprocessor, an original IBM PC, ran at 4.77 million megahertz, or million pulses per second. Today's PCs, they run up to 4 gigahertz, okay? And 1 gigahertz is equal to 1 million hertz. So again, electrical impulses are little spikes, not that occur every second. Try like that occur every well, you have about 4 billion pulses per second, okay? So just wanted to clarify that. Okay, the textbook was not correct there. Okay, what else did I want to take a look at here? Because, and again, things I'm going over will be things you'll be held responsible to on a quiz or test. Alright, the next thing I wanted to go over was memory. And you should know what a kilobyte is. It's 2 raised to the 10th, or 1024 bytes. Now, all of these bytes, if you will, are powers of 2. So one way to remember that a kilobyte is 1024 bytes, or 2 raised to the 10th, is to remember just the powers of 2 for 1 byte. So just to recall, it goes 1, 2, 4, 8, 16, 32, 64, and 128, where 2 to the 7th is 128. So if you just keep doubling that, 2 to the 8th is 256, 2 to the 9th is 512, and 2 to the 10th is 1024. So you should know that 1 kilobyte is 2 raised to the 10th, or 1024. Again, 1024 is a power of 2. Okay, so you should be able to remember that. As well as to remember that a megabyte is 2 raised to the 20th. Okay, or it's again 1024 kilobytes, as well as that a gigabyte is 2 raised to the 30th. or it's 1024 megabytes. Again, you should be able to remember that. And if given a calculation, if you're calculating or changing bits to bytes or kilobytes or megabytes or gigabytes, you should be able to do that. Okay? Again, everything is a power of 2. Everything is a power of 2. Alright, so let me go over one thing here, just as kind of like illustrative what I'm talking about, something like you could see on a test. Okay, so I did a speed test of my internet connection. It's pretty slow today because usually I get download speed of about 360 Mbps, okay, or million bits per second. And then my upload speed is almost 10 million bits per second. So here, what is Mbps? What does it mean? Okay, we have, so I just did this Google search. We have been speaking in terms of higher Mbps and lower Mbps. Let's bring numbers into the mix. Internet service providers usually attach figures to their data. One service plan might speak of speeds of up to 7 million bits per second, another one 10 million bits per second. Data transfer across the internet occur in electrical or light pulses. Okay, how fast? Not one pulse every second. No. Okay, we're talking about millions and billions of pulses every second. The smallest unit of data is called a bit. Okay, the rate of data transferred is measured in seconds. Therefore, the slowest speed of data transfer possible is 1 bit per second, 1 BS. All right, so my connection here was 1024 million bits per second. Okay, so that's bits. So if I divide that by 8, because there's 8 bits in a byte, I get, let's see here, 12,800,000 bytes. And then if I were to divide that by 1024, because there's 1024. Okay, so 1024, so because there's 1024 bytes in a kilobyte. So if I take 12,800,000 and divide it by 1024, that would give me 12,500 kilobytes. So again, you should be able to make that conversion like from million bits per second, the speed of my internet, to kilobytes. So that would be a good example of what I mean. Something you should be able to do on a test. Okay, so the next thing here I wanted to go over is let's take a look at this. So we are on our way to beginning Java, but before we get there, chapter 2 gives an introduction that's going to be important. You'll read that. You'll read that for your assignment today. All right, so here I did want to go over this here, okay, just to cover some things here. All right, so I want to take a look at this is something I present in AP Computer Science Principles. We're going to spend a lot of time in this class working with classes and talking about abstraction. And so what is abstraction? At its simplest level, it's the removing of details, the separations of concerns, the strategy for handling complexity. Okay? So you may think of abstraction in some term that you're familiar with, but in computer science, we're talking about making things a lot easier. Okay? So let's look at the ladder of abstraction here. If you go down to the basic level of computer, down here, it's all physics, and that's something my DE students would say. And down here at this level, okay, things get very, very hard, right? Okay, very, very hard. It's a great deal of thought that occurs down at that level. All right, so as you move up the ladder of abstraction, the next level is voltage and current. And again, probably a little easier to understand than physics, but nonetheless, it still could be somewhat difficult to comprehend. As we move up further, we get into bits and bytes, the zeros and ones. Okay, and that's where we kind of like operate at DE as well as at the voltage and current level. Then we have lower level languages. We're going to look at assembly language. Okay, you'll see that you'll be quite happy that you don't have to program an assembly language at one time. You had the only way you could program a computer was to program an assembly language. But and then as we move up the ladder of abstraction, again, things are getting easier in AP Computer Science Principles. We work with Scratch. And if you've ever worked with Scratch, you realize how quite easy it is to work with. And then as you move up to the top of the ladder of abstraction, you may be working with something like Microsoft Excel, where you have built-in functions and you don't have to worry about any programming and so on and so forth. Okay, and so we'll be working at, certainly won't be working at the low-level language, but we'll be working with the Java, which is one step up. Just to keep that in mind, the ladder of abstraction, it's making things, it's removing of complexity and details, making our lives a little easier. Okay, so here the CPU is the central processing unit. Our programs are turned into instruction understood by the CPU. Grace Hopper. Okay, I saw a PBS documentary on Grace Hopper. Quite excellent. If you're I would encourage you guys in your free time to Google that and go through that documentary. She was quite a remarkable person. But here, thankfully, Grace Hopper invented the compiler. In your reading, it's going to talk about a compiler, a computer program that lets programmers work with more human-readable language. Okay, we'll be programming in something that you can't understand, but then that will get compiled into, in the end, something that's very difficult to understand, and that's only understood by computers or assembly language. So a compiler translated more human-friendly code into a sequence of assembly language code before the code runs. Grace Hopper called her new language COBOL. She received a BS in mathematics from Vassar College and a master's and PhD from Harvard. She programmed the Mark I, II, and III computers and was a rear admiral in the U.S. Navy. Now, here, this is what I mean. So if I go back here, you want to know what is. So we talk about low-level language, assembly language. Here it is. Okay. And basically, every CPU has its own set of assembly language codes, if you will, opcodes. And these opcodes would be things like you see here: move, add, CMP, JBE, and so on and so forth. And so basically what's happening here is that when you write a program, it gets compiled into assembly language. And all assembly language does, it's used to move data in and out of computer registers and perform calculations. So what you see here is these opcodes managing data, loading it in and out into computer registers, and doing some calculations. But again, that's assembly language. We never have to worry about that. Okay, we never have to worry about that there. All right, let's see here. What else did I want to talk to you about? Okay, you'll come across some of that in your reading. I'll talk about assembly language and compilers, but I didn't want to, it's always nice to see exactly what it is you're reading the text, although they do give you a snippet of assembly language code in your reading. All right, but that's just be thankful you don't actually have to work with assembly language. All right, if you ever go into the industry and you're working like with embedded devices, like these controllers that you use to play these games or whatever, these devices, handheld devices, well, not even, you can program that into Java, and then that could get compiled into assembly language. But sometimes some electrical engineers actually have to work with assembly language. Okay. Now the next thing, okay, so we'll be working with Java today. So let me go out to the internet here, and on this website, skylight.com publishing. If I go out here, just do a, what did I do? I did a Google search of Java Methods textbook, and then I got there. I'm going to look at the download files for students, and it'd be helpful if you download those. It will help to keep from having to type things in. Okay, when we start to work with NetBeans, at least that's okay in the beginning, but eventually you won't be able to copy and paste things, and you'll have to do everything by hand, and that's really the only way you'll learn by programming. So you probably want to go out and download these student files. Now, what I have done here, because I'm just going to go over one of the examples, I'll show you exactly what you need to do when you do that. All right. Okay. So here I've downloaded that, and I'm going to open up NetBeans, Apache NetBeans, my IDE. Because in chapter 2 we actually get started working with a little bit of programming. Well, I really won't say it's programming; it's more understanding because everything's given to you. But anyway, I'm going to start a new project here. Okay. So I'm going to start a new project, and I'll select a Java application. And then I'll go next, and I'm just going to call the project name C2 Examples. Chapter 2 Examples. Okay, I've already done this, so it already says it exists, so I'll just go C2 Examples, C2X, and then I'll click Finish. Okay, and there puts in my it created my project C2 Examples. Don't worry about the package right now. Again, when you do your reading today, it kind of make mention of what a package is. But here, I'm not going to worry too much about the details right now, except for this public static void main. And every Java program needs a entrance point, someplace where everything starts. Okay, and that happens within main. All right, that happens within main. So what I'm going to do, so you know that file I downloaded, I had to unzip it, and then there's some. Let me see here in student files, chapter 2. Hello. Okay, here maybe I'll just do greetings. Okay, I think I did greetings. Now I would suggest that you guys get. I use Notepad++. Okay, I use Notepad++ a lot. So what I did, I just opened this up and edit with Notepad++. Okay, you can open it up in any text editor, but I open it up in Notepad++. And all I'm going to do is copy the entry point for this Java program, public static void main. Okay, I'm just going to right click on that, copy, go to NetBeans, and then I'll copy over this public static void main. Alright, so I'll paste it. Alright, so we're not going to worry too much about what's going on here, otherwise again, because we're just learning about the Java environment. We're really not learning about programming right now. But here, so when I run this in this run project, I know I'm going to get an error, and I'll tell you why. But when I run this project, if you look down here, when I run it, yep, exception and thread main Java array index out of bounds, index 0 out of bounds for length 0 at yeah. So I know what's going on. Anyway, the way this bit of code here is set up, and we're not going to work at the command prompt because in school you don't have access to the command prompt, so we'll never be passing arguments into a function to work with them because we can't do that, not in school. You can do it at home, and the textbook kind of shows you how to do that, but I never worry about that in this class. So what I'm going to do, because basically when this main program or main object, when this starts here, it looks for this main method. Okay, and at this point here is string arguments. You can pass in arguments to that function, to main. Okay, so anyway, because I'm not working at the command prompt, I was not able to pass it any arguments. And right here, args0, so it's looking for the first argument, which is okay, but there's none, and then the next one is looking for the next argument. So all right, but so what I'm going to do, and that was a problem there because I didn't run the program at the command prompt and pass in arguments. So I'm just going to because file name is a string, I'll just type in done within quotes, and that's how we work with strings in Java. And then we work with strings with quotes, and I'll just type in Winston. Okay, we're not using any arguments right now. Now if I run it, it runs successfully. Hello Don, congratulations on your second program. Okay, so very briefly what I'm doing is I'm defining two variables in this Java application. They're of type string. It could be integer, float, boolean, double, and those type of things. And then I'm going to call some system commands, system out, and one of the commands I'll call is print. ln means print line, so I'll print a new line down to the console down here. Okay, but that's how you can make your life a little easier as you're learning this stuff, particularly with chapter 2. Download the files, which will save you some time in having to type all of this in. Okay, and I strongly encourage you to do this on the PC. Like I said, eventually I think we'll get access to NetBeans using our Chromebook, but Chromebooks are pretty small, right? And as you just saw, you're downloading files, you're copying and pasting, and so on and so forth. A PC is going to make your life a little easier. All right, so that's it. So kind of a long overview, but again, guys, we're on our way to working with NetBeans in Java. So